Hi, this is Jason Schleifer. Welcome to Animator Friendly Rigging Part 2 of the DVD Masterclass series. In this part of the series, we're going to be focusing on starting a biped rig. In this case, we're going to be focusing on the torso and the head of the character. Now, you may be used to creating heads and torsos in many other ways and many other packages. What I'm trying to go for here is continue what we learned in the first part of the DVD series, which was how to focus on what's actually necessary for the animator, and then come up with a way to create what the animator needs in a way that's easy and fun for them to work with. Okay? So let's go ahead and get started.
So one of the most common types of rigs that you're going to have to create as you start creating animation rigs for your animators is a bipedal rig. That means a rig that has two legs or 2 feet, usually a humanistic or a people-ish type animation rig. You'll find that you probably will be working on these types of rigs 75% of the time, depending on what type of studio you work for. If it's one that's doing creature work, it may not be quite bipedal, but a lot of the same rules are going to apply as if you were just creating humanistic characters. So what we'll do is we'll take a look at that as a great way of introducing you into how to create animation rigs that your animators are going to really love. So how do you know what to do when you start creating a bipedal rig? Well, the first thing you need to do is, of course, look at reference and start sketching and get an idea for the types of motion and the types of poses that you're going to need to be able to create. So, for example, with a human rig here I've got a character that's walking. It's your animators aren't going to be very happy if they can't move the character around, so you need to be able to account for the fact that, yes, the character is going to be moving around and walking. Here, standing with his hands on his hips. That's another great thing that you need to be able to do. That means some sort of inverse kinematic solution where the hands will stick on the hips and the elbows will do the right thing. Here you've got a character lifting up a box. Something that people may need to do is lift things up. Here you've got one pushing a box with his body getting a nice straight line through here. Maybe the character likes to run. Yay, happy run. You can see you get a nice curve going on all the way from the head down through the back and into that leg. Here you've got an inverse curve of a character being very depressed, sitting on a bench, maybe got stood up for a date, and then after sitting on the bench, he goes to a bar, hangs out, puts his elbow on the table, puts his head in his hands, and drinks a martini to make himself feel better. These are all things that people need to be able to do. But obviously, sketching isn't the best way to figure out what types of motions you're going to have, because maybe you're not a very good artist. Maybe sketching only shows one pose and you want to actually look at things in motion to really understand what's going to happen. So it's very important to go out and get reference. And I know a lot of people absolutely hate getting up in front of the camera and dancing around and looking like an idiot and making a total fool of themselves, but you gotta do it. So, in order to help you get past that, hesitation to get up there and jump around and wave your arms, a bunch of friends and I got together, put on totally ridiculous outfits, and went to downtown San Francisco and filmed ourselves running around like crazy doing this fake parkour, free running, urban, stylish running around basically. And we had people staring at us and pointing and laughing, but we figured that, you know what, for you, it's worth it. If we can get you up and out of your chair and moving around and testing your body and seeing how it moves, then the ridicule and the laughing and the pointing and the children crying and the years of therapy, they're all totally worth it. So go ahead and take a look at that video, and then we'll come back and start working on our biped rig. So we've gone and collected the reference, and you've watched it, and you've analyzed it, and you've had a really good time checking it out. But I want you to check it out again. And this time when you watch it, start looking at the various parts of the body and thinking about how they move. And not just how does the back move, but what part of the back stays still and what part of the back moves. When the character's pushing off here, for example, when I'm sitting and then I'm going to push forward and I'm pushing off and I'm releasing, look at different parts of the body like the hand and try and figure out what's happening. The hand stationary as I lean forward. As I push off, the hand starts to roll forward. My arm straightens, goes from a curve to straight, and then releases as the character the character comes forward. What happens with the back? It's curved but relatively straight, then it curves more, the shoulders hunch up, then it kind of pushes forward and then straightens as I lift off. So these are things that you should really be looking at when you're analyzing reference to figure out what to do. You want to look at not just what the poses are, but how things are moving, where they're pivoting from, and what's not moving when something else is. The reason why you want to do this is because that's what animators do when we're looking at our reference. We're always thinking, where is the motion coming from? What's driving it? Where's the pivot? Where's the weight? And if we're doing this and we're using your tools to create our motion, you should be doing this as well, so you know that you know exactly what we're thinking about and you can anticipate our needs. Because that is stuff that animators love. We think it's great when you do things like that. So, we're going to start working on our biped now. So how do you actually figure out what to do when you start working on the rig for your biped? Where do you start? What happens? What do you do? Well, the first thing I like to do when I start working on a character is think about the character the way people talk about it. If you're doing a biped or a human, people talk like this. He put his arm over there. She moved her leg. He dropped his head sheepishly. She socked him in the gut. Blah, blah, blah. Things like that. What they do is they talk about the body part in ways that make sense. He put his arm over there. That means that basically if a character were to actually do that, that would break down to he lifted his clavicle, lifted his upper arm, twisted the arm, raised the forearm, broke the wrist, lifted the wrist up, maybe spread the fingers a tiny bit, then started dropping his upper arm, and then let the forearm fall behind, and blah, 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 blah. So if you broke it down into the individual bones, that would be a little bit complicated to talk about. People don't speak that way. They say he put his arm over there. She moved her leg. That means she probably lifted her hip, then raised her thigh, and then brought her lower leg, etc., etc. But again, we don't talk like that. We just say she moved her leg. And that's the way animators are going to be thinking about what the character needs to do. I have to put his hand on this. I've got to move the body over there. I've got to dip the head. I've got to do this. They'll analyze that motion and figure out what body parts are necessary to do that, but they think in terms of well-defined sections of the body. So, if you break up your rig into those sections, it's going to make it a lot easier to think about those body parts as they move around. So, for example, here's your body, and then there it is, broken apart into convenient sections that make sense. You've got the head, you've got the torso, you have arms, hands, legs, and feet. You could probably break those up even further and say hands and fingers, and feet and toes, and head and ears and neck, etc. But for a start, this is a great way of thinking about the body parts because the torso really is important in and of itself. The hips and shoulders are very important together. With the arms, you've got to know where the shoulder is, you've got to know where the elbow is, you've got to know where the wrist is. With the hands, you really can't work on the palm without the fingers. You need that stuff. So I like to break the body part into sections like this, big sections, in order to think about how I'm going to rig it. If you need to break it up further, that's fine. And then if you need to make it smaller, that's fine as well. It really depends on the character, and for me, this is a really helpful way of doing it. Now that we've broken up the body into these sections, where do we start? We've got 6 sections here. Do we start on the head? Do we start on the torso? Arms, the hands, the legs, the feet? What do we do? What I like to do is actually work on the body part that's going to affect the most other body parts. If I start on the head, that's not really affecting much except the head. If I move it, just the head and ears and nose and eyes and stuff are going to be moving. That's fine, but it doesn't really give me a good idea of what types of things the character needs to do. If I start on the torso, it's going to affect the arms, the hands, the head, the legs, and pretty much the feet as well. It's going to affect everything because everything is connected through the torso. If I start on the legs, those pretty much just affect the feet. So for me, starting on the torso is a great place to start because that's where all the motion comes from. That's where everything moves, and that just is the most important part for me. So we're going to start there with the torso. So now that we know we're starting with the torso, what's our first step? Guess what? It's getting reference and analyzing it. So we've got a bunch of movies that come with the DVD where you can take a look at a bunch of areas from the parkour DVD where we've analyzed the back. So let's take a look at those movies. Now, while we watch this movie, I want you to really pay attention to what's moving, what's not moving, and kind of abstract the motion into a way that makes sense. So that'll give us an idea of what we need to do when we start working on the back rig. In this one, you can see that I lean forward and push off the ground. Just go and push off. So let's look at what the back is doing. If we step through, You'll notice I've got a curve on the back, which is looking very computery. It's a very comfortable way to sit. You got a nice arch, hunched forward, so that when I'm older, I'm going to be very decrepit and funny looking, but that's all right. I'll do that for my art. I don't care. Then as we scrub forward the back, I lean back, and then I start to hunch forward, and you'll notice the top part of my back moves faster than the lower part. My butt is pretty much stuck on the ground here, and my shoulders are moving down. Then as I lean forward, my bum starts to roll forward and lift up a little bit. My back starts to straighten as I push, and then I arch my back as I keep going. In this example, we have Carlos doing push-ups. Now it seems like a pretty simple type of motion that he has to do. His back is pretty much straight. There might be a little bit of flexing happening as he hits his extreme on the way up. But take a look at where his body's actually pivoting from. As he moves, his body's pivoting from his knees. Right there. The back stays straight, but he's pivoting around an axis, like right around over here. So if we were to be animating this, and our body's pivot was here at his hips, where it would have made sense to do for me getting up off of that seat, what you would have to do is translate the hips up and then translate them back and then rotate and then translate down, and you have to animate them moving in an arc like that, which would be really difficult. However, if you were able to move the pivot back over here and then animate like that, it would be a lot easier to get the motion that you want. So maybe that's something that we need to look at for our rig. In this movie, Jason Nocipa is bouncing around, and you can see some great motion between his hips and shoulders. Really extending and getting a lot of overlap and follow through. So let's take a look and walk through this frame by frame. As he gets ready to jump, you can see he stretches his back and then drops his head and shoulders down faster than his hips. So his head and shoulders are moving faster than the hips. Then his hips hit the ground and his shoulders start to lean up, and he arches his back and gets this great line of action right through here. So his back is curved and twisted, and then it hunches over as he starts to come down. His hips are moving faster, he extends, then he hits the ground, his hips stop, the shoulders overlap, he bounces up, and then again twists his hips and steps forward, and then launches again. Woo! Twists his back, gets a great straight line right through there. Arches his back, and then lands with his hips and his shoulders and overlaps. Like that. So you can really see the difference between what the hips and shoulders are doing and see how they interact together. And finally, in this movie, you get to see me make a fool of myself as I jump and then fall and land. Pretty hard. Very hard. I could have broken 30 bones from doing that. But anyway, so let's take a look at that and analyze the skill and technique necessary to do this. So if I run forward, you'll notice that I arch my back backwards like this, pulling my shoulders back, pushing my hips a little bit forward. I jump, arch my back more, and again my hips are coming up, my shoulder starts to duck down, and then as I push off, my back extends. I get about 37 feet in the air, get this nice curve going through here, like that. And then as I come down to land, completely off balance, but doing it on purpose. Hit the hips like hit the ground first, start to go up, the shoulder overlaps. And then as I come down and hit the ground, my hips hit first, and then I roll, for safety, so I don't break anything. And then my shoulders hit the ground, and they kind of stick as my hips pivot over the shoulders. Boom, hips hit the ground, shoulders come up, head whips, and then settle. So there you can see again, the hips and shoulders are relating to each other quite a bit, and by the way I'm moving, by the way they move defines the rest of what my body's doing. So you can pretty comfortably say that it is the relationship between the hips and shoulders that defines the action of the torso. Basically, whatever they do will define the arc, will define the twisting, will define the attitude, define the emotion. The hips and shoulders really define it. All the stuff in the middle just sort of comes along for free. Let's take a look at a very simple example. Here it is, me just leaning forward and getting up. Well, this isn't really me, but you know, it's a drawing of me. So here we've got the character leaning back and then leaning forward. So when you lean back, you can take the shoulders, pull them back, leave the hips there, lean forward, the shoulders can lean forward. And that's about it. Very simple. It'd be a very easy rig to create. You just create a joint going from here to here and then there and back, and that would give you the arc. Create another joint, or then you rotate it forward, and that gives you exactly what you want. Very, very simple. But, you know, unfortunately, our animations are never really that simple. Let's take a look at a more complicated example. Here we've got a walk. Believe it or not, walks are very complicated. You've got to have the hips twisting independently of the shoulders. So here, hips are twisted facing towards the left, shoulders are facing towards the right. Then they switch. You've got the back leaning backwards, as it would do. You also have this side twisting, because this is a very hip walk. He's going, yo. I don't know if yo is what you do these days, but back in the day, that was what you would say when you were walking hip. You'd say yo, and then you walk, and then you strut. You do your thing. So you've got to have the ability to twist sideways, and you need like a really nice curve, an arc in there. So this is a bit more complicated. So how can we go ahead and do this? Well, you could create a very simple joint chain, something like that, where you've got joints that go up and down, and then you can bend them. But the problem with this is if you want to bend this and get this shape, there's a lot you actually need to do. For example, if we switch over to Maya, you'll see here's my straight up and down, and what I want to do is bend over to the side. So I would have to rotate this bottom joint over, and then notice as I rotate over, the other joints are following with. I've got to rotate back, and then I've got to rotate back, which is fine, but if I want to make any changes, this can get very difficult. Let's take a look at an example. Here we've got a wrestler in a wrestling pose, and his hips are here. Let's say this was the bottom pivot, and they go up towards his shoulders. Now what if we want to lift his hips up, like he's getting ready to actually do something interesting, like wrestle? So we want to lift the hips up, but leave the shoulders where they are because he's intense. You know, he's like, ha, I'm right here. So you have to translate the hips back, and then rotate, and then go forward, and then rotate, and then, you know, this could get very, very tedious very quickly. To have to go between those two positions without moving the head is a real pain. So using just pure FK may not be the right solution for us, because we want to be able to move the hips and shoulders independently. But we also need to rotate everything and get twists and get all sorts of stuff like that. So analyzing this, we can come up with some rules for what the back needs to do. It's very important for you to write things like this out because it will help you determine what you need to solve before you actually start working on anything. So, what are the animation requirements for a torso rig? Well, we need to allow for rotation of hips and shoulders. We know that because we need to be able to make the character walk and sit and do all sorts of stuff like that. We also need to make sure that that rotation is available in all axes, bend, twist, and side. It's important to specify this because if you don't, you may forget about one of them. We also need to allow for independent motion of the hips and shoulders so we can do things like the wrestling pose. We need to be able to move the hips independently of the shoulders. Cool. So how do we start doing this? Well, before we actually start anything, let's take a look at a couple of control possibilities to see if this really suits all of our needs. One thing I like to do a lot is test things out. As I'm thinking about ideas and trying to think about the animation requirements, I like to just sort of open up a quick version of Maya and try stuff and see if it's going to work. So let's go ahead and do that. So let's take a look at control possibility number 1. This is an FK back with the pivot down at the root. That's down at the bottom. You can see that it's got 3 joint segments, bottom, middle, top, like that. And the way this works is you can basically select the bottom. This acts like the hip. Grab it, rotate it, etc. You can also go ahead and select the next 2 joints and save keys for them and rotate them. And the nice thing about this setup is that if we have auto key turned on and I move it and save a key and I go over to say frame 10 and grab this guy and move him like that and maybe rotate him this way and then go to say frame 12 and take these 2 and go like that, what'll happen is you can see we get some really nice overlap and follow through all relatively easily. like this. So it's really easy to get nice arcs and follow through and stuff like that with this type of setup. So that's a good control possibility. Let's take a look and see what possible problems there might be with this solution. So you can see we have some pros here. There's predictable motion, small number of controls, it's only 3, similar to real life. In real life, your hips control everything, and then your back is basically forward kinematics all the way down from the hips to the shoulders, and it's easy to move in arcs. Some of the cons are it's difficult to make changes. If we go back in here and let's say you want to have the shoulders at this specific spot here on frame 6, so you really want them to be right there because that's where the head is, but you want the hips to be over here. In order to do that, you've got to move the hips over, rotate them back like this, grab these guys and rotate them back, and you can get it generally in the right area, but it becomes really quite poppy and difficult and a little bit frustrating to try and manage all that without having odd motion, without having to counter animate really difficultly. Independent motion, not easy to achieve. You can't just pull the hips over. You can't do that sort of wrestling move that we were trying to do earlier. And spine compression is difficult. That's something that I found is really important, especially if you're doing dynamic shots where you've got characters jumping and bouncing and stuff like that. You may have somebody falling like this from up here to down, boom, like that. And what you want to do is, as they fall, you want to compress the spine. And what you end up doing with this situation here is going, okay, well, if we rotate this like that, and then we take these guys and we rotate them in, that should do it. And then here we'll rotate them back like that. You can kind of do it, but it becomes really tedious and there's a lot of counter animation. And if you ever then decide that you want to change the way it's done, for example, maybe I want more compression on the lower hip here, then you've got to take these guys and then rotate them back. And you can't just take the shoulders and move them down and rotate them independently as you would want to. And you see how I'm getting this sort of like woo little loop that happens in the motion there? I may not want that, and that makes it really difficult to get rid of. So those are some of the cons of having a FK control with a pivot at the root. But what about maybe an FK control with a pivot at the mid-back? Let's take a look at that one. Alright, so here we go, an FK control with a pivot at the mid-back. The way this works, if we take a look here, is this is actually where the joint, the pivot is. It's right in the middle there. So I can move the body from here, I can rotate the whole thing around, and you can see that it's pivoting from right there, basically right above the hip. The nice thing about this is I can take the hip and I've got some independent motion here that I can use. I can rotate it without affecting the upper part of these guys, moving them. So what is good about this type of situation? Well, you got some independent motion here, which is really nice. It's a little bit easier to do that spine compression thing I was talking about, and you still relatively get some nice arcs automatically. Small number of controls, etc. However, with some of the cons, it's not easy to achieve complete independence. If I want to pull the hip over here, I still have to go like this, and then I still have to rotate these guys back. And in fact, this is even more complicated than the other one, because, well, do I rotate the root to get where I want, or do I rotate just these two to get where I want? So it starts to get a little bit more complicated. And like I said, yeah, it's basically just more confusing. So that's probably not going to work. Let's take a look at another example. So maybe some independent shoulder and hip animation controls. Alright, in this example, if I take this piece, I can move this around. This represents the shoulders. And then I can take the hips and move them, and that represents the hips. Now this works pretty well because all I need to do is just click and drag, and I move what I want. I've got two controls that kind of manage the entire thing, and they do exactly what I want. This is a lot easier to do things like spine compression. As you can see, it just like this. Let me turn on lines so you can see this. We'll just go shading, wireframe unshaded. There we go. So this is a lot easier to control. So what are the positives about this type of situation? Well, you have total independence of hips and shoulders, which is great. There's a small number of controls. It's just 2 of them. It's easy to tweak. If I want something specific, like let's say I have a shot like this, or a frame like this, here, where the character is leaning forward, and then I've got a pose back here where he's leaning back, and in between these, I really want to make this kind of cartoony. I can lean forward, and then maybe scoot down like that, and then whoop, up like this. And so it's really easy to get fast animation like that and just make it look exactly how you want. I love animating this way. Love it, love it, love it, love it, love it. Super easy. It's really nice. I could even have him like, you know, come up this way a little bit. Boom. Maybe bring this frame a little bit earlier. This is great for doing really snappy style animation. So, easy to tweak. Spine compression is a piece of cake. Allows for unique cartoony poses. The cons. Arcs can be more difficult to achieve. Now, obviously, you have total control over what the different pieces do, but it's not as easy as setting a key over here and setting a key over here and getting a nice smooth arc. So for fast motion, it's really easy to get arcs, but if you've got very slow motion, you have to spend a lot more time tweaking your translation animation curves to get a smooth arc. So what about maybe control possibility number 4, a combination of FK and IK? The pros are all the pros of 1 and 3. Let's take a look. So here we've got an FK and an IK back. You can see the FK is this yellow spine here. If I click it and drag it, the IK follows along, and then I can grab the IK and move it away from the FK control. The great thing about this is it gives us exactly that very nice slow motion that can still move in an arc, but then I can go in and offset on top of that. Using the IK and get exactly what I want. So we've got a couple things here which are really, really useful for us. We've got FK to get exactly the slow, smooth motion for arcs. We've got IK for tweaking and minor offsets. Or I can just take the IK completely, ignore the FK, move the IK away, and just use that doing what I want. Same way I could before with a pure IK system. So those are the pros, all the pros of 1 and 3. The con, once the spine is pulled away, it's tougher to create nice arcs. Once I've pulled that away and now I try and rotate here, see how the spine stretches like that? That's because this control is a child of this joint right here. So when that joint moves, it moves the control. So is that really a big deal? Well, you could probably rig up a system where you've got the IK which follows the FK and then have a switch that'll jump the FK to the IK position, and that's something that would be really, really wonderful and fun to have. But I found that for 95% of the animation I've ever done, I've never really needed that. What I'll usually do is look at the shot and figure out what type of motion I'm going to be doing and what the best solution is for that, and then I'll use either the IK or the FK and just stick with those methods, and that seems to work very well. So for me, combination of FK and IK is the best control possibility of all. I absolutely love it. I use it all the time, and it works great. Okay? But the big question is that enough? What happens if we run into a situation that's not really covered by just a person walking around? What if, for example, you've got this character that's flying through the air? What's the best solution for that? Do you want the pivot to be located right around their hips? Probably not. The best place to put the pivot when somebody's flying through midair is in the center of mass, maybe right in the middle of the back. So if we have the pivot here, right at the hips, it's going to be really difficult to do things like spin him around and stuff because he's always going to be pivoting around that point, and we actually want him pivoting around this point. So looks like we need to add an animation requirement. So we've got allows for rotation of hips and shoulders, allow for rotation in all axes, bend, twist, and side, allows for independent motion of the hips and shoulders, and allows for the movement of the pivot. Sweet! That's going to give us all of our requirements. Awesome! So now, before we actually start rigging up our character, what I want to do is take a look at something called the Torso Rigging Toolkit. And what I like to do is basically I call this thing a toolkit because what I usually do is I'll just sit there and start exploring the different ideas and figuring out how to do them and what each little part of the rig means and what's going to work best before actually getting in and building the rig. It's the same thing we did on the bouncing ball in the Animator Friendly Rigging Part 1, where we tried a whole bunch of things to see what would work best. We're going to do the same thing here with the torso. And like I said then, if you're going to be practicing, let's say if you're a pianist, you play piano professionally for a living, you're really good. The first thing you're going to do when you sit down at the computer, the first thing you do when you sit down at the piano is actually practice your scales and warm up. So that's what we're doing. We're practicing our rigging and we're warming up before we dig in and create a rig like the maestro that we are. Okay? So let's go ahead and start exploring the Torso Rig Toolkit. So what types of things are we going to need in our quote-unquote toolbox in order to work with a back rig? Well, we're going to need FK joint control because we know that we're going to be using forward kinematic joints. So we need to be able to do that. We're going to need independent controls for the shoulders and the hips. We're going to need spline IK to guide the objects between the shoulders and the hips. We're going to need to be able to stretch the joints in order to allow for that compression, and we're going to need to be able to do some pivot relocation. So let's take a look at each of these and make sure we understand how they work before we get involved in any great deal in our rig. And the first one we're going to look at, of course, is the joint creation and what it is to actually create a joint, how we orient them, and how we understand the joint length, since that's going to be imperative in our rigging toolkit here. So before we do too much with the joints, I want to just take a look at what a joint is for those of you who are kind of new to Maya, and even for those of you who aren't. It's a good idea to just really understand what joints are before we get going with them. So in Maya, I'm just going to create a new scene, and then we'll go ahead and create a joint. And we'll just go Skeleton, Joint Tool, and we're going to click anywhere to create a joint. As soon as I click, it automatically puts one, and I'm going to hit the Q key on the keyboard to exit the tool and sort of validate. So this is a joint. This is basically a special type of object in Maya that is unique because it has a location, a rotation, and an orientation, which we'll get into in a second. But that basically means the position, the rotation value, and an axis that it orients along, which is called the joint orient. But it doesn't make much sense without a child joint. So let's go ahead and actually create a child joint there. Go back to the joint tool. And now I'm going to just create a joint segment. So we'll click once and click twice. Notice that when I clicked once, I created one joint. The second time, as soon as I clicked, it created a segment between the two. This is known as a joint segment. This means that in Maya, in order, basically the way Maya works is you've got a position for the start of the joint and a position for the end of the segment there, and that defines the joint segment. The length of this is basically the translation in X of the second joint, of the child joint. So that means right now this is 2.373, which means the length of this joint segment is 2.373. So there we go. So if we look in the outliner, we can see that only these two joints exist in the scene, but Maya automatically draws that connection between the two so we understand how they're related. The cool thing about this is that it really starts to give us an idea of what the skeleton might look like. For example, if we were to go to a side view and create something that looks like that, you might recognize that as an upper arm, a lower arm, and then possibly a wrist. So even though it's just 3 positions in space, joint 3, joint 4, joint 5, it looks kind of like an arm, especially if we start doing things like moving it. So we go whoop, rotate it up like that. You can see, woo, that looks like somebody pumping iron. A very skinny person pumping iron, but someone pumping iron nonetheless. So you can start to get an idea of how these things relate to each other. So let's take a look at now, we know about position, because we can move this and we get its position. Let's take a look at the joint orientation and rotation and understand how those work together. If we take a look right now at the rotation values, you can see that joint 1's rotate values are 0, 0, and 0. However, it's oriented at this child joint, which means it's aiming in that direction. So even though the axis, the world axis for rotation is z going along this way, x going along that way, and y going up, if we switch to our rotate tool, you can see that it's pointing down at this child joint. Joints always work best when they do that. It's extremely important to understand how rotation works because it allows us to control how our joints are going to move. Let's go ahead and take a look at an upper arm and see what I mean and how orientation can be important. So if we go ahead and go to a side view in a new scene, we'll go to our skeleton tool, go to the joint tool, and then I'm going to switch over to the option box here so we can take a look at what the joint options are. You'll notice we have things for degree of freedom. This is the orientation, which we'll be talking about, second world axis orientation, and then a few other settings. So our main thing that we're worried about right now is the orientation. So let's set that to none, and then I'm just going to click 3 times to create an arm. So we'll go click, maybe there, and there, just like I did before. So now we've got a joint, an upper arm, a lower arm, and a wrist. Let's go ahead and create another arm, but this time with the proper orientation. We'll go back to the joint tool and set the orientation to X, Y, Z, just the default. And we'll create a second arm. So we'll go click, click, click. And notice that these joints themselves are actually oriented and aiming down along the joint at the children. You can see that just looking at the little cross that represents, or the little plus sign that represents the joint. Notice how this one is straight up and down, and this one is aiming down at the child, like that. So you can see exactly how they're working. If you have trouble actually seeing the rotation axis, what you can do is click on these guys and go Display, Transform Display, Local Rotation Axis, and this will give you a better idea of exactly what's happening. Instead of just the direction, you can actually see the axes and where they're pointing. In this one, you can see that Y is up, Z is forward, and X is coming straight towards us. In this one, Y is going that direction, Z is coming towards us, and X is aiming down along the axis. So each one of these is different. This one was created with a joint orient of none. This is created with a joint orient of X, Y, Z. So how does this really affect us? Well, if you try rotating the joints, you can start to see immediately what happens as soon as you start doing things like twisting the forearm. In this case, if we go into the rotate tool and I want to twist this lower arm, you can tell that with my rotations there's no real easy way to twist along this axis. Whereas with this one, because the joint is oriented this direction, I can grab the rotate X and just twist. If I go here and grab rotate X, well, it bends it. Rotate Y swings it around that axis, and rotate Z swings it around this axis. I can't just sit here and twist it. Whereas with this one, it's very easy. Rotate X moves it up and down. Rotate Y goes side to side, and rotate X twists. Very easy to work with and much easier to understand for the animator what's going to happen. So we'll get more and more into joint orients and how this all makes sense and what they're doing as we get further along. I just wanted to introduce the concept to you so you can understand, first of all, a really simple example of why this is kind of important. Okay? So now we understand about joints. We know how to place them. We can control the length, and we know the length of the joint segment by simply looking at the translation value of the child. So here at translate X, the length is 5.299. If I go like that, the length is 1.938. I go like this, 9.129. Very important, those numbers, 9.129. If I want both of these joint segments to be the exact same length, I can simply select both those joints and say to translate X is going to be 5. And now they're both 5 units long, each of them. In some programs, instead of having the two joints representing the length, they'll have the position, orientation, and rotation and a length value itself. And then the joint's length is just an attribute on here, and there is no child joint that represents the actual length. But in Maya, this is the way it works. Okay? So we know the position, we know the rotation, we now at least understand that orientation is important, and we understand length. So let's go ahead and take a look at one of our other things we need, which is some independent shoulder and hip control. Since independent shoulder and hip control is very important to us, let's go ahead and try and come up with a way of doing that within Maya. In this case, what we're going to do is create two cubes that we can use as examples for the shoulder and hip controls. Let's step back over to Maya and create a new scene. And we're just going to create two polygon cubes. So we'll go create, polygon primitives. I'm going to turn off interactive creation. And then just choose a cube. And then we'll duplicate it and just move it up in Y, like so. And there we've got our two cubes sitting in space. Very exciting. It doesn't do us any good to have two cubes just sort of sitting here and not really knowing what's what. So let's go ahead and rename them. I'll show the outliner here so we can take a look. Let's take pcube1 and we'll call this hip_anim. Remember from Animator Friendly Rigging Part 1, we always name things as we're creating them because it makes it easier to figure out what you're doing, especially when you're testing ideas. You don't want to be, trying to figure out what you've got and going, okay, now was poly 473 x7 delta 4, was that the scapula or was that the toe? What is that? Nah, it's much easier to go, oh, okay, that's the toe, so I'm going to name it toe. In this case, we have hip_anim and shoulder_anim. So let's move these around. This is going to simulate what it's like to manipulate the hips and shoulders. Hey, look, I'm a shoulder. Woo! I'm going to move this way, and I'm going to rotate, and yay! Woohoo! That's pretty easy to work with, isn't it? You just sort of move them. There's the shoulders. There's the hip. Rotate that way. Rotate that way. Yay! But it's kind of missing something, isn't it? We can move these around, but we're missing the guts. We're missing this whole bit. So this is the thing that the back we need to figure out how to do with the back. Is how to actually create the guts and create the stuff and then control it so that when we rotate the hips, we get a nice smooth interpolation between, or when we rotate the shoulders or hips, we get a nice smooth interpolation between the two of them. So we need to figure out how we're going to do that. And for what I'm going to do, there's actually a number of different ways of creating all the guts and controlling the guts. I'm going to use the Spline IK system because it comes with Maya and it's relatively easy to use. There are a couple other ways of doing it. There's something called the ribbon spine, which you can do. I think there was something called a nifty spine. There's all sorts of different techniques out there. This is one that I've used repeatedly and it's pretty stable, and I like it personally. So we'll go ahead and take a look at that. But if you have another way of doing a spine, then by all means, you're more than welcome to use it. There's no one answer that's the bee's knees for everything. There's things that work right now, and then who knows, maybe tomorrow there's going to be some brand new technology that comes out. So what I'm trying to do with this is actually to show you examples of how it works and why we're using it. Not, you should create a spine with this tool because it's the way to do it, but more like, this is what the tool is used for and why we're going to be using it. And if you have something else that gives you what you need better, then you can totally do that. Okay? So let's go ahead and create some joint segments for our spine, and we'll use the Spline IK to do it. Alright, so we go back to our scene here. I'm just going to go to a side view, and we'll go ahead and create a joint segment. So we'll go here from the top of the hip, and then hold down Shift and go straight up to right underneath the shoulder. Okay, so since we're going to be creating a spine that's going to bend, we're going to need a few more segments than what we can see here. And I'm also just going to change the joint size here so it's a little bit easier to see these as we segment them. So right now we've got one joint. We're going to want to segment this a few times. So you can either click a whole bunch of times to create a joint segment. So for example, I can go over here and just go click, 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 click. But it's kind of difficult to know that these are all going to be exactly the same length. So instead, what we can do is use a script that comes with your DVD package called JS Split Cell Tool. Whoa! Very exciting. The JS Split Cell Tool is actually available here on your shelf, or you can type it if you want, if you're a typing kind of guy. But basically, if you click on this, it'll tell you to split the selected joints a certain number of times. So I can say split it 8 times, and it'll break it up into 8 joints. Or I can say, 8, that's ridiculous, I don't need that many. Maybe 6 times. And go, that looks nice. Maybe I can say I only want it 3 times. Like that. And that'll give you 3 joints. I think 6 is going to work for us for the back. Usually somewhere between 5 and 6 joints does a good job for the back. So we'll choose 6 for now. And then let's go ahead and make these a little bit smaller still. There we go. Shabloink. They are smaller now. So there you go. On your tool, on your shelf right here, split selected joint. That'll do that for you. Now these joints are all equally the same length, which is great. Makes things a lot easier. But one of the other things that we want to do is actually be able to see what's going on with the joints without, like right now we've got the geometry for the hips and the shoulders, but we don't have any geometry for the joints. So we want to see that. So I'm going to select each of these joints. And right next to the split selected joint tool, there's something called Add Geo to Selected Skeletons. If I click on that, that's going to assign geometry to every single joint. And as you can see, it's automatically got different colors for two different sides, one for the side, one for the front, so you can get an idea of how the thing is twisting. And if we open up in our outliner, you can see that it's named them appropriately according to the joints, even though those are kind of ugly names. But if we were to name things correctly from the beginning, the geometry would be named right. Okay? And if I select a bunch of these joints and rotate them, you'll see that the geometry moves with it. Much easier to see what's going on, and a lot quicker than having to just sit there and click and add geometry a whole bunch of times. So, now that we've got that, we want to create a spline IK control that's going to go through all of our joints in the back. The spline IK will take each of these joints and snap them to a NURBS curve, which means that you can then manipulate the curve very, very quickly and get a nice, smooth arc. So to do that, we're going to go to the skeleton IK spline handle tool and go to our option box. And then what I want you to do is set the handle options, or set the options for the IK spline. So you have root on curve turned on, auto parent curve turned on, auto create curve, and auto simplify curve. Everything else is fine. And then what we're going to do is click on the first joint, which is joint 1, and the last joint, joint 2. And what that does is automatically creates an IK handle that goes through all the joints and a curve that we can then manipulate. So if we go into shaded mode there and switch into component mode, so we can select these. Oops, we don't want to pick those guys. So we can pick these points here. As I move them, you can see exactly what's happening. You've got the joints which are following along this curve that automatically gets created with the spline IK. And you can get a really good idea for how this thing is going to move. It's very fluid and very nice. Looks almost like a little chunky caterpillar. Little earthworm or inchworm. And that's how the spline IK works. It just sort of lays those joints down along that curve, which is exactly what we want for the back. Now our goal is to actually have these points move along with the hips and shoulders control, so when we move them, the curve itself, these little CVs will go and stretch over there. Okay? So there's a couple ways of doing this. If you are familiar with Maya, you understand that you can do things like grab these joints and do create a cluster, and then you can move that cluster around. You could parent the cluster to this control, and then when you grab this guy you can move it and that'll deform the curve. That works pretty well. But I found recently that one thing that I really like to do is, instead of using clusters, is actually just use regular skinning, because it gives me a little bit more control over the fall off between the various points in the curve. So to do that, what we're going to do is go skeleton joint tool, and we're going to create a joint right there, and we'll create another one right here. So we've got joint 3 and we have joint 4. And the way I'm snapping those, we'll redo that again for you real quick, is holding down V, which does point snap. And while I hold down V and click with the left mouse button, I can move this around and snap it anywhere. And if I go on that joint, it'll snap it to the joint. Then I hit Y to go back into the tool and snap right there. Joint 3 and joint 4. All done. Sweet. So what we can do now is we can name these joints, which is going to be probably a good idea to just rename everything just to make it easier to understand what's going on. We'll call this back joint. we'll go to the IK handle. We're going to name this back IK handle because there's so many things coming in here. It's starting to get a little bit confusing. Back curve. This is shoulder joint, and this is hip joint. Okay, so now we want to skin back curve to shoulder joint and hip joint. So I'm going to select all of these, and then we're going to go to skin, bind skin, smooth bind, and go to the option box. And what this does is this allows me to say, basically, I want the CVs on this curve, the things that we were picking and moving around, to be moved by the shoulders and the hips, and I want it to be weighted based on the distance between the two. So we'll choose bind to joint hierarchy, which is going to be fine. Closest in hierarchy or closest distance, I'm going to switch that to closest distance. Max influences is 5, and drop off rate, all that is fine. We'll leave it there. And then we'll say, OK, boink. And that creates that. Now if I pick shoulder joint and move it, you can see that it pulls the curve around. I can take hip joint and move that, and it pulls the hips around. So what we want to do now is just sort of parent these correctly. So I'm going to drag the shoulder joint onto shoulder anim, drag the hip joint onto hip anim, and now when I move this, I get the motion that I'm looking for with the back in terms of this guy's moving around. So I can go back and forth, and it moves. Yay, very exciting. But you'll notice something about this. There's something wrong here. I can grab this and move it and rotate it, and I get some really nice motion, but you can see that the back is pulling away from the shoulders. I don't want that. I want that to actually stretch along there. So we need to figure out some way to stretch the back so it matches between the shoulders and hips. But you might be saying, wait a second there. Hold on, Jason. You can't stretch the back. In the real world, backs don't stretch. You can't actually take your torso and drag it up twice as high as it is like the natural distance between your hips and shoulders. That's painful. You would rip your spleen or something. But we're not in the real world. We're in animation land, which means we can do whatever we want. And the animator's job is to keep the character on model and keep it looking like themselves. So if I'm animating this, I'm not going to have a pose which looks like that. That's going to look really lame. I'm going to have a pose that looks like this and stays on model. But the thing is that when I'm manipulating and I'm moving this thing around, I want the back to stretch. I want it to feel very fluid, like I have total control. I want to be able to grab this and move it over here and have this stretch, and then go like that, and then get it to line up correctly. Because I want to make sure that I have the ability to move things without being hampered or limited by the rig. It's very important for you to allow the animator to just sort of move things however they want and let them make sure it looks correct. So, how do we determine the scale, or how do we determine what to do with the joints to scale them up to match the back? Well, figuring out the distance and how to stretch the back isn't just a matter of going, well, how far are these guys from each other? If you just measure that distance, you're going to get a straight line from there to there. What we want to do is actually look at the length of the curve itself and determine how to stretch the joints along that curve. Notice here, if we just grab the distance, you get that straight line. But if the curve is doing this, we want the curve length. We want to find the length of that curve. So how do you find the length of the curve? Luckily, there's something in Maya called an arc length node, or a curve info node, where you can grab the arc length of the back. So when you go like this, you say, I want the length of that arc between those 2 points and what this thing is doing. So to grab that, we'll just grab it using the curve info node. So let's set that back. And to create a curve info node, what you do is you select the back curve. And this involves a bit of typing. So luckily your documentation comes with the exact commands that you'll need. So we'll bring up the script editor here, shrink this down a little bit so we can see what's going on. Shoo-hoo, right there. And what we'll do is we're just going to type arc len minus ch1, and what that means is find out the arc length, connect it to the node, to the curve right here, and keep construction history. So I do that, and you'll notice that it's created something called a curve info 1. If we take a look into our hypergraph, and we've got our curve selected here, right there. Let's take a look at the nodes. You'll notice that on the back curve shape, there's something leading into our back IK handle, and there's also something leading into curve info 1. If we select this and take a look in the attribute editor, you can see the arc length of the curve is 1.954. That's basically the length of the curve when it's basically straight up and down. I'm going to go ahead and tear off the attribute editor here just by going copy tab, poink, and we can see it. And this way we can watch what the arc length is doing while we manipulate the curve. Notice here as I drag this around, the arc length is changing. If I rotate it, the arc length increases. If I drag down, the arc length decreases. So what we want to do is actually tell the joints to scale based on what the arc length is. Right now, each of the joints has a scale value of 1 because that's what they come in as default. So imagine if you were to take this joint or this control and bring it up twice the value that the arc length currently is when it's at its default, you would probably want to scale each of the joints up to 2. If you were to take it by half and scale it down like that, you'd want the joints to have a scale of 0.5. So we have to figure out what the math is in order to get that. And don't worry, it's pretty easy math. For me, it's difficult, but for you guys, a piece of cake. So we'll just sort of draw this out to help get the idea. I'm using the little paint tool that's inside Maya, and I'm drawing with a mouse, so it's going to be a little bit tough to figure out. But we know that this is the basic rule. The joint scale has to be somehow related to curve scale. Rel to curve. Right? So somehow the joint scale, JS, that's me, is related to the curve scale. SC. Okay. So we know that by default the joint scale is 1, and let's just pretend that the default curve length is 2. Okay? So if our joint scale is 1 and our curve length is 2, this equation doesn't work. We need to somehow tell the equation to do something with 2 to make the value equal to 1. Otherwise, we don't know what to tell the joint scale to be, because we know, well, joint scale has to be 1 in order for these lengths to be currently what they are. So what do? Well, if we do look at our normal idea of fractions, you know that anything divided by itself is going to be 1. So we could say that the joint scale is equal to the curve length divided by itself. Curve length. And that means that joint scale is always going to be 1 no matter what the curve length is, which isn't what we want. That doesn't make any sense at all, does it? Because the curve length is going to change, and we need to tell the joint scale what to do if the curve length changes. For example, if the curve length is 4, we want, which means it's double what it originally was, we want the joint scale to be 2, right? So if the curve length is twice what it normally is, the joint scale should be 2. So what do you have to do to 4 to get 2? Well, you could divide it by 2. That's kind of interesting. Okay. Let's say that the curve is half the length. Let's say we're shrinking it down. So it's half of 2, which means it's going to be 1, right? And we want, when the curve goes down half the length, we want the joint scale to be 0.5, because that's half of what it originally was. This is how I always figure out my math expressions. I just sort of throw in some values and try and figure it out. So what can we do to 1 to make it equal to 0.5? Well, 1/2. That kind of makes sense, right? 1/2 is equal to 0.5. So what we're doing here is we're saying, well, if I know that this value here, let's see if I can change the color. I know that this is my joint scale right there. And then somehow this represents the length of the curve in order to give me the math for that. But what I'm doing here is I'm doubling the length of the curve and then dividing it by something to get the new joint scale. And here I'm halving the length of the curve and then dividing it by something to get the joint scale. It looks like what I'm doing is I'm saying that the joint scale is equal to the current curve length, current CRV, divided by the orig CRV. And what that does is, if the original CRV curve is 2, then what I'm doing is I'm saying, well, the joint scale is going to look at the current length divided by the original, and that should give me the joint scale. Or the back scale is going to be equal to the current curve length divided by the original curve length. There's a bigger explanation of this in the documentation if that makes sense, but basically that's what we want. Isn't that fun? Yeah! So how do we actually do that? Well, there are two ways of doing that in Maya. You can either use an expression or you can use a node. This is what an expression looks like. It's a bunch of text where you can kind of figure out what's going on. This is what nodes look like. Here you've got the curve info node passing into this multiply divide node, sending into all these joints. What I like to do when I'm testing my rigs is I do everything with expressions because they're really easy to change and very easy to read and figure out what's going on. Once I know exactly what to do, then I'll recreate it in nodes because these will generally evaluate faster than some text that Maya has to parse and understand. So what we're going to be doing with the course is mostly doing things through expressions because it's easier to understand. But once you start understanding it, feel free to recreate things with the node format. So the first thing we want to do is change the name of this back curve info node because it's kind of confusing right now. It doesn't really tell us what it is. It's just called curve info 1. So I'm just going to double click on it over here in the channel box and change it to back underscore curve info. So now I know when I want to find information about the back curve, I just go straight to that. Yeah, which is good. And then I want to grab the actual length of that curve info. So if I go into my channel box, or my attribute editor, click on that, I can grab this value, 1.954, and we'll just paste it down there for later use. So it can be used handily. Then I want to start renaming these joints. Notice right now I've got back underscore joint, joint 1, seg 1, joint 1, seg 2 joint. It's a bit confusing. I want to just rename these so they're a lot easier to find and a lot easier to understand what we're working with once we get into the expression. So what we're going to do is use this hash rename script that's on the shelf, comes with the DVD. Click on that, and then you can simply do back underscore hash or number sign, whatever you want, underscore joint. And then it'll automatically rename based on that hash. You can actually use as many hashes as you want. So for example, back underscore hash 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 joint, and it adds zeros beforehand. Back underscore hash underscore joint. Basically, anywhere there's the number sign or the hash, it'll rename with the proper number. Very handy script, saves you a lot of time. Okay, so then we're going to go and create the expression to stretch these joints along the x-axis. Boink. We take scale x, do 2. It'll scale along that axis. That's what we want to do. So we're going to create an expression to do that. And we'll just go to Window, Animation Editors, Expression Editor. Now, one of the things I like to do in the Expression Editor is really comment my expressions a lot so I understand what they're for. Because otherwise it can get really confusing if you have a ton of expressions and you don't know what they're doing. And this way you can go back and read them and understand, etc. So I'm going to go over here and I'm going to say this is the back scaling expression. These little slashes right here mean that I'm writing a comment, which means I can read it later. So the first thing we want to do is determine the back scale. Let's determine the scale of the back. Original back length is 1.954. That's the value that we grabbed from the back curve info node. And remember our expression that we determined, the math that we were going to, where the back scale is going to be equal to the current curve length divided by the original curve length. So we'll enter the same thing. Scale is going to be equal to the original curve length, the current curve length, which is back underscore curve info dot arc length, because that's the attribute, divided by 1.954. That's our scale. Cool. Now that we have the scale, we want to apply that scale to all the scale x attributes on the joints. So we'll do back_1_joint dot scale x is equal to scale. And then I'm just going to copy this and paste it a whole bunch of times. And we'll choose back 2, back 3, back 4, back 5, back 6. We don't need back 7 because that's the last joint in the chain, so that's not going to scale at all. It's just going to be those 3. We'll click create, which will be our expression. And then, if I close this, and I grab this guy and start moving him, you'll see that the back stretches to match the length. Pretty handy, right? It does exactly what we want. Stretches, and it keeps the length even when we're twisting and scaling, or rotating, and stuff like that. So, that is awesome. We can rotate, we can translate. So what's next? Unfortunately, watch what happens if we twist. The back doesn't twist with it, so we need to come up with a way to do the back twist. So you can see we can create the controls and stretch it. We can control the guts. We can use the spline IK to stretch, but we don't know how to twist the back. So how do we do it? Well, in order to figure out how to twist the back, we have to understand how the IK spline system works with twisting. Let's look at the attributes that come with it. Go ahead and select the back IK handle. And then if you scroll down in the channel box, you'll notice that there's a couple of attributes here down at the bottom that deal with twisting. There's twist and roll. Let's take a look at what each one of those does. If you use the twist attribute, it will twist along the back. I'm just clicking with the middle mouse button and dragging left and right. And that's kind of what we want, right? If we grab this guy and move it, and then we grab the back IK handle and twist, we want to do that. But unfortunately, that's a real pain for the animators to work with. Let's see what the roll does. If I take the roll attribute, it just rolls the entire thing, which is cool because if I move the base and the hips, I kind of want the whole thing to roll like that, and then I would want the twist to go backwards to line up with the shoulders. Because what we really want is this thing to basically do whatever the hips and shoulders do and just sort of follow along with it. So you could use the twist and roll attributes, but again, that's kind of painful for the animators to keep going back there and picking and grabbing and rotating and all that stuff. They're very interesting controls, but they're not the best that we have for managing how this works. What we want, like I said, is for the back to just follow the hips and shoulders, so it's just those two controls to work with. So let's figure out how we can do that. Luckily, the IK Spline Solver has some very cool stuff here. If we go to the IK Solver attributes in our attribute editor, you'll see there's something called the Advanced Twist Controls. So I'm going to open that up. And these are advanced controls that allow us to do much more complicated things than just grabbing the twist and roll. We can actually set things to look at vectors or up objects, etc., etc. So let's take a look at them. The documentation goes deeply into detail about how this works, but for right now, we'll just enable it, and then we're going to talk about what each of these things are. There's this world up type attribute, which will tell us what the spline IK is going to follow. Basically the hips and shoulders, or if it's going to look at the scene, or etc. You've got the up axis, which is going to tell the axis what controls we consider up. You've got up vector, which, if you don't understand math, it's a little bit confusing, but basically that's a direction. Vector is a direction. You got 1 and 2 for the first object and second object. You got the world up objects 1 and 2, twist types, and a whole bunch of other things. But what we really need, and basically what we're going to be looking for, is to set the world up type to the correct thing. And what up type means is what we want the spine to consider is up. What does the spine think the direction is up? Now, when you say what's up in a 3D scene, you probably think straight up and down, right? But for the spine, that's not actually up. For the spine, this is not up. What is up? If we look at joints, remember how we have the aim along, so the joint's here and it aims at the child and it aims at the child? The up axis is basically pointing 90 degrees from that. That's the up axis. So imagine if we were to take this joint structure and rotate it back 90 degrees. Aim along is going up, the direction you would consider up. and the up axis is actually pointing back that way, which means the up axis for our spine is pointing back along the back of the character. So up for us is going to point back this way, or negative z. So what we want to do is change, how do we, basically we want to make it so that the spine understands that that's up. So how do we do that? Well, if we change our world up type to object rotation up, start and end, what that's going to allow us to do is set a start object, which is going to be our hips, and our end object, which will be our shoulders, and tell the spine to follow the rotation of those two objects. So what we'll do is we'll tell it the world up object is going to be hip underscore anim, and the world up object 2 is going to be shoulder underscore anim, like that. So now we have to determine what the up axis is going to be. We've got our two objects here, hip and shoulders. So what is the up axis? Well, if we look back at our image, you can see we're using the back as up, so that's going to point that way. Well, if this is our world axis right here with z forward, y up, and x coming towards us, what is our up axis? It looks like it's pointing away from z, so it's negative z, right? So if we come in here, we go to our up axis, you can see here's our options. We'll choose negative z, and that's going to point back that way. Now what we want to do is set what our up vector is. So if we go and we take a look at our first joint down here, go into wireframe and we pick that, and we go display, transform display, local rotation axis. You can see what the local rotation axis is. So right now X is aiming along the joint, Z is should be facing towards the front of the character, and Y axis is going off to the side, like that. What we want to do is keep the joint orientation, so we're going to use the negative Z, which will be used for the up vector. Whoop. So we'll go over here and we'll set that to 0, negative 1, that to 0, negative 1, like that. So now if we grab these and rotate them, you can see that it does exactly what we want. And because it's interpolating between those objects, we get a very, very smooth, nice twisting happening, like that. Okay? So again, what we did was, we came in here and we said our up axis is going to be negative z, which is facing along that way. And I want the joints to do the same thing. I want their negative z to be the one that's considered up, since this is negative z that we're going along. Cool? Let's go ahead and turn off the display of that joint. Display, transform display, local rotation axis. Cool. Now there's one small problem that we've hit. Remember in the previous class, in part 1, we talked about rotation orders. Well, we haven't actually changed our rotation orders in this class. We're going to get into a lot more detail about rotation orders later on. But for now, if you remember from last time, it's important for us to make sure that when the animator rotates the character 90 degrees, that we don't hit gimbal lock. And right now, we are hitting gimbal. So we're going to change the rotation orders for each of the shoulder controls and for the hip controls, where we want it to be either ZXY or XZY. Doesn't really matter which one you want of those. It's up to you, personal choice, but I'm going to choose ZXY. And again, if you're confused at all about the rotation order, please check out Animator Friendly Rigging Part 1, because we get into that quite a bit. But we will be talking about it a lot more a little bit later. So we have our rotation orders set. We have the character being able to move around, we can rotate it, we can do all sorts of great things with it, we can bend it, and the back moves along with it. But notice, as I move the shoulders up and down, what the back is doing itself. Notice how it's staying the same width. See that? It's the same width when I go up, the same width when I go down, etc. Now, for me, this is kind of a big deal because it just sort of takes away from some of the believability that this object actually is something besides just this never-ending stretching, thing of power. I don't know what it, but it's like, it could be this long, it could be this long. I have no real reference point to say how long this should be. If this was a character's back and I had it up here, there's nothing telling the audience that maybe he's stretched up and really arching his back really far. So what I wanted to do was add some sort of volume preservation. So as I pull the shoulders down, it would actually bulge out the spine to give us a little bit more grounding in reality. Even though this is stretching around like taffy, it's good to make sure that it's based in some sort of real world physics, kind of. So why don't we go ahead and try and do something like that with just modifying the expression that we've got there. So let's go ahead and bring up the expression in our expression editor. Go to select filter by expression name. There it is, expression 1. Let's change the name of this expression to back EXPR so it's a lot easier to tell what it is. And we'll go ahead and take a look at it over here. So here is our scale that we've got. Now remember, with the bouncing ball example, when we wanted to squash and stretch that and keep volume, one of the things we looked at was using an expression like this. INV scale is equal to 1 divided by square root scale, like that. So that means that as the ball squashes down, it's going to get wider. As it lifted up, it would get skinnier. So we'll do the same thing on the back. Okay? Now let's add to the end of this. The comment is inverse scale for, whoops. I should look at the keyboard when I'm typing. Inverse scale for volume preservation. Back 1 joint scale y equals inv scale. Scale z equals inverse scale. So there we go, and we'll copy that, paste that a few more times, and then we'll just change these like this: 2, 2, 3, 3, 4, 4, whoops, 5, 5, 6, 6, and voila. Click edit. We'll close that, and now notice what happens as I stretch up and down. The back will squash and stretch, keeping its volume. Yay! Very exciting. It stretches, it squashes, we're kind of keeping the volume, and it's doing pretty much what we want, except it's kind of boring. Notice how it's stretching and scaling the exact same across the entire back. Well, that kind of sucks. That's really boring. What if we wanted to create something that was a little bit more interesting, where instead of having the back, when it stretches out, go and just be like that, we want it to actually do a little bit of an hourglass shape. So it looks like it's getting thinner in the middle, as opposed to just staying the same size. Kind of like if you had gum on the bottom of your shoe and you were stretching. So let's see if we can figure out some way to do that. So let's take a look again at what's happening here. As we scale down, all the joints are scaling out evenly, and all the joints are scaling in evenly when we scale up. What we actually want to have happen is for each of these joints, when you squash in, we want the amount of scaling or difference to increase for the middle number of joints and sort of stay consistent on the first joint, the second joint, and then the sixth joint and fifth joint. So we kind of want to ease into that. So how can we actually do that? How is it possible to scale those in the middle joints more than the outer joints? Let's take a look at the expression and see if we can come up with a way of doing it. So we'll go to our selection filter again, make sure the back expression is selected. And you can see right now that the inverse scale here is consistent for each one of these. But what we want to do is slowly increase the middle ones, like joints 3, joints 4, joints 5. So joint 4 is kind of like the biggest, like that, either 3 or 4 gets the most amount of scale. And 5 and 6, or joints 5 and joints 2 don't get as much, and joint 1 and joint 6 probably stay what they currently are. Well, there is an expression we can use that does that, and it's called the POW expression. And we could do something like POW inverse scale say 1.5, like that. Pow, inverse scale, 1.5. And what that does is that raises the value of the scale to 1.5. It works like this, where 1 to the power of 1 is going to be equal to 1. 1 to the power of 2 is going to be equal to 1. Always. No problem. 2 to the power of 1 is equal to 2, but 2 to the power of 2 is going to be equal to 4, and so on. So if we have values of the scales as they increase or decrease, this first value here is going to be changing. And so if we give it something to raise to, or go to the power to, then that value is going to increase. So like here, when the back is at its normal size, the inverse scale is set to 1. But as the scale increases or decreases, we're going to be raising that value to a higher power. To a higher power. So we're going to quickly add these pow values here. So I'll just go pow, 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 pow to everything except for 1 and 6. And then we'll say maybe to 2. Copy that, paste it. And then maybe for joint 4, we're going to go to 2.1. And let's try 1.5. Again, on here. So I'll edit that, close it, and let's take a look at what happens. Now notice that as I squash and stretch, the joints in the middle are getting more of that squashing, or more volume preservation. So it looks a lot more realistic. It's a lot more interesting. And you can keep it pretty subtle, but it adds just a nice little, like, yeah, this thing's grounded in reality. There's an actual length that's kind of its default. And as I pull away, that's actually doing something to the guts inside the character and trying to keep him relatively normal in size. You know? Cool. Alright, so let me just put this guy back down to normal here. Boop. So this gives us a lot of control, but what if we want to change that? What if we want to make it so that when he stretches down, we actually want this to bulge out a whole lot and go really, really big? Well, unfortunately, this expression is kind of tedious to work with. If you have a large amount of joints and every time you want to work with them, you got to go edit, expression editor, back expression. Okay, let's see. So we want to increase the POW here to maybe 4. And this one to 3.1. Let's try that and see what happens, and edit that and close it. And then you go back and you test and you're like, no, that's not what I want. You know, that kind of editing can really take a while. What would be great would be able to use something like this, a curve like this, that would allow us to control the power of the stretching there. The power of the stretching. You know, basically bring up something in the graph editor, sculpt it the way we want, and have that be the thing that applies to the scales. That would be very nice, wouldn't it? Well, what do you know? We can do it. There's a way of doing it because Maya is all about creating curves like this and animation curves. Let's go ahead and take a look at how we can do that. So the first thing we need to do in order to create that thing is actually give a place on the animation control itself for there to be a curve. So temporarily, I'm just going to add a place like that. We'll go to the shoulder, and we're going to create an attribute. Go modify, add attribute, and we're going to call it shoulder. Let's see. No, let's call it backstretch. Now it has to be of type float. We're going to say OK. So now we've got an attribute on there called backstretch that we can create a keyframe for. So let's go to frame 1 and we'll save a keyframe for that value of 1. And we'll go to frame 6 and save a keyframe, key selected. I should actually save that on frame 1, shouldn't I? And what we're going to do is pretend that every single one of these keys, so frames 1 through 6, represents a joint 1 through 6 because these are the back controls that we're going to use. So back 1 is going to be affected by the value of that control on frame 1. Back 2 will be affected by it on frame 2. Back 3 will be affected on frame 3. 4 on 4, 5 on 5, and 6 on 6. Okay? Cool. So let's go to frame 3 and let's set that to say 2, for example. Now if we take a look at our graph editor, you can see that we've got an animation curve in here, but what I want to do is actually flatten all these tangents to make sure it eases out of the first frame and then into the second one and then out of the last one. So we'll just go and flatten the tangents by clicking on that, which gives us this very nice curve. So now this is great. We have an animation curve that changes over time, but it doesn't actually do anything, right? So we need to grab the value for each frame and do something with it for those joints. So luckily Maya has a node which allows us to do this. It's called a frame cache node, and what it does is allows us to get the value of a point on this animation curve at a time other than the current time. So we can ask it, hey, what is the value? What's your value at frame 2? Okay, cool. I want to do something with that. What's your value at frame 3? All right. What's your value at frame 5, etc. Doesn't matter what time you're on, you can get that value. So let's go ahead and create that. We'll bring up the script editor, and we're going to type create node, which is the mel command to create a node, and it is called frame cache. So I type that, I execute it, and I get this thing called frame cache 1. And there it is, frame cache 1. So we're going to rename it first of all. So it makes more sense, like back 1 cache, because we're going to use this for the first back joint right there. And then if we select back 1 cache and hold down shift and get the animation control, and then we bring those up in the hypergraph, we can start to look at them. So we're going to choose panels, hypergraph panel, new input out connections. And there you can see there's the shoulder anim and there's the back cache, just like that. So if we choose Window, General Editors, Connection Editor, so we can connect these two together. We're going to select the back cache, click Reload Right, select Shoulder Anim, click Reload Left, and then down at the bottom we're going to choose our back stretch attribute, and then over here we're going to connect that to the stream. So what that means is the shoulder anim's back stretch attribute is going to be driving the stream attribute of the frame cache node. And that means that we can, because the stream is going to be driven by this, that means that now we can grab values at a time other than the current time, which is very, very cool. So let's close that. But how do we actually get that value? Well, if we look in the attribute editor for the back cache node, you'll notice that there's something here called vary time. So this is what tells us what frame we want to grab a frame at. If we say frame 3, we'll be able to get the value of whatever that controls at frame 3. If we set it to frame 1 or vary time 1, we'll be able to get the value at that. So if we now go to our expression editor, go to expression editor there, and we bring up our back expression. Let's minimize that. What we want to do is on the scale Y for the back 1 joint, we want to choose inverse scale, which is what we've got. But instead of actually using inverse scale, what we're going to do is choose a POW command in here. And we'll go POW inverse scale, and we're going to, instead of just entering a number like we've got down here, we're going to tell it to do back 1 cache, and then the attribute is called varying. And that basically means that grab the value of the back 1 cache at frame 1, or whatever it is that we have the vary time set to in the attribute editor, like that. So copy that, paste that, click edit. We'll close this, and now if we go back to our graph editor in here, and we take this first value like that, and we move it up and down, we should see, as we move up here, this value here changing. So notice that as I drag it up, it stretches up. As I drag it down, it's going to get bigger and bigger and bigger. So when it's at 1, it's at the default. But we'll just say that when we stretch away, we want this to get this first joint to get really, really skinny. And when we get down, it gets really fat. So notice how now we have total control over what that looks like just by modifying the curve. Now, obviously, modifying this curve is only affecting this first joint. The problem is that this is kind of a pain to set up for a whole bunch of joints, right? Because you've got to set up one of these frame cache nodes for every single joint that you're going to be working with, which can take a while. So luckily, there's a script that comes with Maya that, or not comes with Maya, but comes with the DVD that allows you to do this a whole lot easier. Let's go ahead and bring this back down to there, and we will use the script. But before we do, we have to get rid of this back cache node, so we're just going to delete that. Do delete back one cache, like that, and we'll break the connection on that. Break connections on backstretch, so we don't have to worry about it. And the name of the script that we're going to be using is called JS create curve control. There's documentation about how it works in the script itself, but here's basically what you're going to be doing. We're going to open up our outliner, and we're going to select each of the joints that we want to work with. So that's back 1 joint, back 2, back 3, back 4, back 5, and back 6. And then we're going to type the following command: JS create curve control space shoulder anim, which is the name of the animation object, back stretch, which is going to be the name of the attribute, and then POW. And that POW attribute is going to be the thing that we grab. Instead of the frame cache node itself, we'll just connect to the object's own POW attribute. So, if we execute that, you'll notice a few things. First of all, backstretch now has keyframes on it again. It automatically adds keys, and it automatically adds a curve which looks like that, which is pretty easy to work with. Each of the joints also automatically has this POW attribute on there, and the scale controls are already in the expression like we have before, so they're controlled. But this POW attribute is automatically hooked up to a frame cache node. So if we take a look at the hypergraph and we check out the new input and output connections, you can see what's going on right here, where we've got the joint, we've got the scale being driven, we've got the frame cache node, which is this guy right here, being driven or driving the POW attribute, and you can also see that the shoulder anim backstretch is driving the frame cache. So that automatically gets created. The nice thing is that means that with this one animation curve, we can change this for all of the scales. But we need to actually use the scales in the expression to make this work. So if we go to our expression editor, and we're going to now modify this expression so that in here we change this to be back underscore one underscore joint POW, like that. And we'll do this for each one of these. Boop, 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 boop. That, and that, and that, and this. And make sure we get these for 6 as well. Joom, joom. And then change the value of these ones so they're their individual power attributes. 6, 6. Click Edit, Close. And now as we move this up and down, you can see we get that squash and stretch, but let's say we want to make it so that when we pull this up, it gives us a lot more than what we've currently got. We'll go to our panels, take a look at the graph editor. Here's the curve, like that. We can just grab these 2 bits and start pulling them up. And notice how modifying this one curve affects the stretching that we've got automatically. And in fact, we can make it even a little bit less linear. If we just grab this guy and do something like that, we can make it so that it stretches a whole lot in the beginning and the weight's down towards the bottom, or we can grab these and pull them up this way. Whoop. like that, and this one, and now all the stretching and stuff will happen mostly up at the top. So this gives you a lot more control to modify things and work with them in order to get exactly the type of deformation that you want to make things look best for your animator. So really, really cool and really easy to work with once you get it set up. So again, just to help explain how this create curve control works, the command is JS create curve control. The first thing you put in is the control object. In this case, it was the shoulder control. Then the control attribute, which was back anim or back scale, sorry. And then the driven attribute, which was the POW attribute. So control object, the object has the control animation curve on it. The control adder is the attribute with the animation curve, and then the driven adder is the attribute to be added to the selected joints, and that's the thing that's controlled by the frame cache node. So that's why we can easily add it to the expression and have it work individually with like individual control for each of those joints. Very, very fun. Cool. So with our toolkit now, we can create the controls, we can control the guts, we use the spline IK to stretch the back, we can twist it. We've got unique and interesting volume preservation control, which is very cool. But there's something else we need to figure out how to do, and that is how to create a movable pivot. So let's go ahead and create a new scene, and here we're going to take a look at what I'm talking about when I say movable pivot and how it actually works. Alright, so let's go ahead and create a cube real quick. There we go. There's our cube. And as you know, you can sit here and move cubes around and and when you rotate it, etc., it all rotates from this point in the middle. But if you want to move the pivot to somewhere else, say on the edge of the cube, for example, right over here, you can hit the insert key or the home key if you're on a Mac and move this over and move this down. And very exciting, lo and behold, hit the insert or home again, and now the object pivots from that position. Very easy to do, very cool. However, Animator may not or may not know how to use it or that it even exists. For example, if you were to say to somebody who had never used Maya before and they brought up this cube and you said, okay, why don't you just move the pivot down over to that corner there, they'd go, oh, okay, yeah, I'll move the pivot. If I just go to the let's see, modify, transform, move tool, move normal, move show, no, okay, maybe it's under the snap, no, it must be, okay, it's gonna be up in, no, maybe it's down over this side over here, is it, okay, we have a, move that, what is, oh, it's yellow, okay, what does that do, oh, that doesn't do anything, alright, you know, basically there's no way that tells them what that means. I mean, how would you know to hit the insert or the home key to move the pivot? You wouldn't know. You'd be a genius if you knew. And even though you are a genius, you still may not know, because I'm sure you're all geniuses. So it's very useful, very useful to be able to do this. But as a character TD, it's your job to make sure that if you want them to do this, then you have to show them how to do it. And the good thing is if you show them explicitly what to do and you give them the tools to do it, they won't just start taking every random object and moving the pivot and stuff as soon as they go, oh, I hit insert and I move it. And then all of a sudden things are broken because they're moving pivots off over here and on this object, and another pivot is going to be moved, you know, somewhere else. So I go over here on something else, and etc. So making sure that you give them the explicit tool to do it only on the controls you want will limit them from doing it on controls you don't want, which is cool. So how do we do that? Let's create a locator. Our favorite thing in the world is a locator. We love the locators. Now what we want to do is attach the locator to the pivot itself. I'm just going to move this guy down here to the middle again. So we want to make it that when we move the locator, it moves the pivot. So let's bring up our connection editor, Windows, General Editors, Connection Editor, Shakal. And with the locator selected, we're going to choose Reload Left. Then we're going to choose the cube, choose Reload Right. And on the left side over here, we're going to go down until we find Translate. And we're going to tell the Translate to actually drive the Rotate Pivot. Right there. Doink. Just like that. And what that does is that means if I go ahead and go into our outliner and make it so the locator is a child of pcube1, like that. And we're going to call this p cube 1 pivot, like so. Now, if I go ahead and move the p cube pivot, say over here, and then grab the object to move it, it rotates from there. If I grab this guy and move it, say, over here, it rotates from there. Pretty cool. But notice what's happening is as the object's moved and I try and move the pivot, the object itself moves. That's because in Maya, an object placement is based off of where its pivot is. So when the object is 0 and I move the pivot down over here and then select the object and rotate it, it's fine as long as the rotation is 0. But if it's rotated at all and I move the pivot, it wigs out. It does strange things. If I move the object, let's see what happens if I move the pivot. Nothing. It's fine. It's only when the object is rotated and you move the pivot that it can do some weird stuff. Now this is something that you can't really get away from, but if you give this to an animator, holy cow, they'll be going crazy. They'll be like, I just want to move the pivot there. How come I can't just say, no, I want the pivot right there, but I don't want the object to move? I mean, imagine you're animating the cube tumbling, right? And you start off over here and you say, okay, for the first part of the frame of the animation, I want the pivot to be there, right? So I'm going to save a key on that, and I'm going to save a key on that. Then, say on frame 12, boop, the cube goes like this. So I'm going to save a key there for the pivot and for the square. Then on frame 13, I want to move the pivot right over here. So I go, wonk, and then it's like, but now the sphere's up there, or the cube's up here. So now I've got to move this and put it down there, and then go back and forth, and now, it's popping. Okay, so if I move it back like that, move it back like that, and I go back and forth, it's still popping. Okay, what about there? It's still popping. And the animator's going to spend a lot of time trying to get this to work, just so they can do something like that, and get the animation to go, woo, boo, boing, boing, But they're going to spend so much time modifying this and trying to get it to not pop, it's going to take them forever. So that's not going to work. What we really want is to be able to move the pivot and then move the object, basically make the animator say, I want the pivot over here, and then move it there without the object snapping. So let's take a look at the steps that the animator would need to go through in order to get this to work without jumping. Right? So what they would do, we're just undoing back all the way to the beginning. Boom, there we go. So what they would do is they would say, I want the pivot over here. Rotate. Now let's say I want the pivot to be right here. Well, what they could do is create another locator, or just say duplicate this locator, move that pivot to there, like that, save a keyframe for the translation of this pivot and the object, like that. Then they could get the local position of this pivot, the world position of this object, move the old pivot to the location in the world space of this pivot, which would end up being there, and then move the object up to that new position. And then that way it wouldn't jump. And then clean it up by removing this second pivot and stuff. But that is a real pain. That's a real pain. That's like, that'll drive you crazy. So if you actually want to use this in production, you're going to have to use some Mel scripts to make this a little bit easier. Let's do a file new. Do not save. Create some primitives. So we'll try this again, but this time we're going to use some of the scripts that you get with the DVD. So first one is going to be called JSPivotCreate, and you can use that just by clicking right here on this object. So select any number of objects, but you can do it on just one, for example. So we'll click on that, and what it does, let's take a look at the outliner so we can see what's happening here, is it actually creates two pivots for us. It creates something called the Anim pivot, which has just translations available, and it creates a Move pivot, which is hidden, which also just has translations available. But it's basically two locators, which are children of that object. Okay? So then what we can do is move, or basically if we want to move the pivot, we can do this like we have before, where I select and I move and select that and move. But notice how it starts to kind of mess things up, just like it did before. If we then go and say, click on this button here, which is Show Movable Pivots, boop, you'll see there's this object here, which is the movable pivot. We can move that wherever we want, like here, for example. And then we can say, well, now let's snap the old pivot to that new position. Notice it snapped and the cube didn't move, and now we can move there. Let's go ahead and do the cube rolling example and show how much easier it is to do. So we'll go here. Let's take this, for example, and we'll just take this pivot. This is the normal pivot, and we'll snap it, say, right to there. And we're going to save a keyframe for that, and we'll save a keyframe for the cube. Then I'm going to go to frame 10, and I'm just going to rotate this -90 degrees. Save a keyframe. Now, on frame 11, I want the pivot to be moved to right here. So I go here, I go Show Movable Pivot. It automatically selects it for me. I move the pivot to where I want, which is right there. I click Snap, like so. And now I can start animating. Frame 20. Set that to -180. Like that. And now if we watch, boom, boom. Just that easy. On frame 180 or 120, I can come over to the next frame, show me the pivot, move that over here, boom, click on Snap, maybe give it a little bit of motion, and then just keep going. At any point, I can take this pivot, show it, and move it over here, or move it to anywhere I want, and it'll allow me to just snap right to it. There's a couple of other things here. There's this toggle pivot visibility if I want to turn on and off the irregular pivot, which is pivot anim, and then there's also the move visibility, which is this guy right there. And there we go. Just that easy. So this is something that we can use on the body or any other object that we want. And then again, you just turn off the visibility so you don't have to see it. So the animator, you can give these tools to the animator, maybe not give them the create one because you don't want them creating it if they don't need to. But definitely the show movable pivot, the snap to new position, and the toggle pivot visibility are really good. Something else that you'll notice is with the toggle pivot visibility, that just shows the visibility of these guys. That doesn't actually do anything. The snap one will snap this movable pivot to the location of the current pivot. Like that. Just so you know that it's in the right spot. So it's easy to get to. And then this one will snap the actual pivot to the location of the movable pivot. Like that. And save a key on the previous and current frame. So we've got independent shoulders and hips, creating the controls, controlling the guts, using spline IK to stretch the back, twisting the back, volume preservation, and a movable pivot. Waha! So we've got each of these things. These are now our animation requirements for the torso rig. So what I like to do is write them down and make a little checkbox so I know that I'm going to be meeting the requirements. As I've solved the problems on the rig itself, I can mark them off and I know that I've solved those things. Ding, 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 check, check, check. But remember, from the last class, there are a couple of requirements that we have for every single rig, and we have to make sure that these are all met. If you've watched the first DVD or the first masterclass, you'll know how important these are, so we'll go through them again. For every single control you create, it has to be using simple controls. The animation has to be easily transferable. The controls are unique and make sense. The controls have the correct rotation order. Controls are named correctly. They should only be able to set, and the animator should only be able to set keyframes on controls we want the animators using. Okay? There are also general rig requirements. We should only be able to select what the animators can use to animate, or whatever we want them to animate. There should be a clean outliner, and we should have the ability to relocate the rig and move it around.